Well, my last video I made, it was about this 55 amp hour battery. That one cell shorted in it, got nice and warm. Actually still is warm. You can hear it still outgassing a little bit. So I'm down 55 amp hours out of my 400 amp hour battery bank. So now I'm about 344 or 345. I recovered these. These were free. They're 17.2 amp hours each. So it's about 34 amp hours total between the two. And I never did a video on this. I wish I did, but my battery went dead as I was doing it, which I couldn't stop reconditioning these because I didn't want to risk wrecking them. So I'm just going to show a few things. These are flat. If I would have put any type of load in them when I got it, they would have showed 0. So you can see a digital reading too. Sorry about this. Just trying to get it to stay somewhere just to get a reading. Okay, so about 13.4 volts, exactly what you want to see out of the battery. And we're going to put a 100 amp load. Just for a second here. And we're holding about 600 cranking amps. Went way down. Battery's recovering. That one's a success. Now let's go to this one. You gotta be careful, you're gonna cross these leads over. No, I'm gonna spin it around. So don't have to worry about that. Oh, I didn't even notice. Look at that. That was from the other battery. Now it's a little bit bottom of this battery. Ugh. Anyways. Okay. So this is the second battery. Just tested the first one. Now I'm testing this one. We're sitting at 13.31 volts. That's really good. Load test. 600 as well. 10.43. That is awesome. These things could easily start a car. 600 cranking amps, that'll start almost any car. But what I'm going to do, because I just lost 55 amp hours, I'm going to put 34 back into my system. I was using these on my UPS system for a while. They were great. I could run my computer for 2.5, 3 hours, no problem. But I don't need that because I have a solar backup system. If the power goes out, my laptop's got a battery. I'll just flick a few switches and my house has power. I can charge it, no problem. And I'd rather have this extra battery capacity in my main system than in the UPS. So that's what this video is about. I'm going to hook it up and get back to you guys. Now that I got it all wired up, negative to negative, positive to positive. Oh, I just knocked my lead off. Just doing a quick charge on it because I want it to have the same voltage as my main battery bank when I hook it up. Don't want my main battery bank to be pushing into here at all. And discharging into these batteries. Want them to be the same. And it's going to go in. Got the wires coming out here. They're just charging right now. And then they can go into the battery bank. And then I will show you guys the final setup. They're now hooked back into my system. Or actually hooked into my system for the first time. I have them hooked up with it's either 6 or 8 gauge wire. I'm not 100% sure. Which is enough because these are never going to be really, other than for this test, running this inverter alone. So they won't need really any heavier duty battery cabling than this. These will have between 2 and 4 gauge, so these are much heavier duty. As you can see, two 17.2 amp hour batteries put together is almost exactly the size of a 34 amp hour battery. Makes sense. I added this quick disconnect, spin it, and it disconnects all 3 of these batteries. These are on a separate one. Then I have a bunch banks of batteries. Like I have a bunch of 7 and 9 amp hour batteries, and they're on this shut off switch. Then I have a 55 amp hour battery on this one, and two 35 amp hours on this one. And so then this one have two 34s and a 55 on this one, which is a 400 or 500 amp switch. So I have them all, so if something ever happened, I could just flip them off and work on the system or whatnot. This is the voltage of these 2 batteries. Turn the inverter on. 1.3 volts. I mean 13.3. We are going to run this angle grinder off the two 17.5 amp hour batteries. It did kick off for a second. That is due to these smaller gauge of wire that will have quite a bit of resistance for high loads. While it's running, 12.38. This thing is extremely inaccurate on inductive loads. It's bang on when it comes to resistive loads, though. That's probably closer to like the power factor probably would have been around 40, so that probably would have been about a 200 watt draw off these batteries. But on startup, it probably would have been like 800-900, close to the max of this inverter. Yeah, seems to be working great. So now if I hook up my smart charger, which is right in here, that's this box, smart charger, has starting and deep cycle batteries. I have it on deep cycle, and it's a 10 amp charger, and it's now charging these batteries. I might just fiddle with this for tonight. Maybe just leave these hooked up for now and see how well they work. I know they worked good in my here, focus out here. I know they worked good in my UPS, and I'm sure they'll work just fine in my solar setup. But that's what I'm doing for now in replacement of my 55 amp hour battery. I am looking at getting a 135 amp hour AGM battery to add to this bank, and that'll be equal to all of these right here plus a tiny bit more, so it'll be equal to 3 of these batteries. So it'll be quite a large battery, a nice add-on. And yeah, just thought I'd share that. See ya.